This is homework 9.1. And I am going over question number 1. What we have is negative 6x plus 3y minus 10z equals to negative 2. We have 2x plus 2z equals to negative 7. And then we have 5y negative 9z equals to 3. So then the problem says, write the augmented matrix for the given system. So we have a system of equations, and we want to write an augmented matrix. So our goal eventually in this section is to be able to solve this system of equations. That means we want to find x, y, z, which are going to be 3 numbers that works for this equation and this equation and this equation. So we are trying to, eventually that's what we want to do. But in order for us to find such a solution that works for all 3 of them, if there is any, then one technique is to write this as an augmented matrix, and then we learn how to solve that augmented matrix to give us such solution. So an augmented matrix is a matrix that is 2 matrices that are connected. So first I'm just going to write one matrix that is called the coefficient matrix. The coefficient matrix is going to have these coefficients, negative 6, positive 2. Since I don't have an x here, I'm going to call it 0x. There's a 0x here. Then we go to the next variable y. We write all the coefficients of y variable. So the coefficient of y is 3. There is no y here, so there's a 0. And then there's a positive 5. And there's these guys. Next, we are going to write the next one. We have a variable z. So we are going to put negative 10, positive 2, negative 9. So this is called a matrix. A matrix is made of rows or columns of numbers. This is your first column, second column, third column. This is your first row, second row, third row. These are called entries. So this is negative 6 is located at first location. So it's on the first row and first column. 3 is located on the first row, but is located on the second column. So we call it A12. Let's say 5. 5 is on the third row, and it is on the second column. So sometimes you just have to be able to refer to certain number using those notations, A12, A11, and so forth. So this is called a coefficient matrix. And when you create a coefficient matrix, you have to make sure your system is set like that, where x's are lined up, y's are lined up, z's are lined up, equal sign must be lined up, and then this side is just going to be your coefficients. So in other words, if this negative 2 happened to be on this side, like this, if you had like plus 2 equal to 0, the first thing before you create your coefficient matrix, you have to subtract 2 from both sides. So then your negative 2 is going to be on this side. Then you create your coefficient matrix. So when we have our coefficient matrix, the next thing we want to do is we want to create an augmented matrix. To create an augmented matrix, we are going to put this matrix, which is called B matrix, for instance. It just has 1 column, 3 rows. So we want to connect them. So what I do is I get rid of that. Instead of the equal sign, we put a line, and then I put these numbers, -2, -7, +3. So that's it. For this homework, we had to do this, and I just went through all the explanation. What is a coefficient matrix? What is an augmented matrix? This is called an augmented matrix when you put this one and these guys together like that. So that was the answer. So question number 2. We are given the following system of equations. We have 2y minus 3x equals to 7x plus 6. We have 4y equals to 8 minus 2x. And we want to create an augmented matrix. So remember, we want to have a system that looks like that. We want to have x's lined up, y's lined up. There will be a coefficients here, for instance, and an equal sign, and then your number. So right now, I want this x to move over. I want to distribute the 2. And for the second one, I want to move 2x over. So let's do the first equation first. 2y. 2 times -3 is -6x. Then I subtract 7x from both sides. So let's add and subtract these guys. I have a -6x and -7x. That gives me -13x, and I want to write it first. Then I have plus 2y, because this 2y has no sign. The sign is a positive, so that's an addition. On this side, we have 6. So that's our first equation. On the second equation, we're going to add 2x to both sides. I'm going to write 2x first. Then I have plus 4y, because this is positive, so it becomes addition, is equal to 8. So that's it. Now we have our system in this format. Now we are going to create our augmented matrix. This is our x column, y column. We are going to have a line, and then I will write 6 and 8. The coefficient of x is -13. The coefficient of y is 2. The coefficient of x on the second equation is 2. The coefficient of y is 4. So this is your first equation. This is your second equation. First equation, second equation. This is your x coefficient, and this is your y coefficient. Okay? So question number 3, we have an augmented matrix. We are going to go backward. We want to write this as an equation. Remember, these are your x coefficients, so this becomes x and x. These are your y coefficients, that's a y and y. Since there's no sign, the sign would be addition. And the line is the equal. So those are your equations. So your equations are 4x plus 7y equals to -9, minus 5x plus 7y is equal to 8. And that is our system of equations. So question number 4. We are given an augmented matrix for a 3 by 3, 1, 0, 0, 0, 0, 1, 0, 1, 0, 0, 0, 1. We have a line, and then we have 7, 6, negative 1/6. And it says, write a system of linear equations represented by the augmented matrix. Give your answer in standard form using the X, Y, Z variables. The questions in the system should be in the same order as the rows in the given augmented matrix. So just go ahead and remember, this is your X column. So this is 1X plus 0Y plus 0Z equals to 7. But 0Y is 0. 0 times Z is 0. So these are 0. So you're just left with 1X equals to, this is equal, this line is equal. So you have 1X equals to 7. You don't need to put 1. You just write it simply as X. The next line is 0. The next row, we have 0X plus 1Y plus 0Z equals to 6. But 0Z and 0X is 0. We just get 1Y is 6, or simply Y is 6. Last row is 0X plus 0Y plus 1Z is negative 1/6. These are zeros. We just get 1Z is negative 6, so we get 6Z is minus 1/6. So question number 5. We have 4, 4, 5, 2, 5, 1, 5, 4, negative 1. And then we have 1, 6, 6. For this problem says perform the elementary row operation such as R2, R3. So when we want to solve a system of equations, like let's say this is a system of equation, the first problem, there are different techniques to solve it. One method is we write the system as an augmented matrix, and then we can perform 3 types of operation on an augmented matrix. One of the operations is that we are allowed to do is swap these rows. So I'm allowed to put, for instance, row 202 minus 7, the second row, in place of the first one, and then put the first one in place of the second one. I'm allowed to do that. And then the last one stays where it is. So that's called swapping rows. You're allowed to swap rows. Another operation you're allowed to do is you're allowed to multiply a row by a number and add it to another row. So for instance, I'm allowed to multiply 3 by row 1. So I multiply 3 by 2. 3 times 2 is 6. 3 gets multiplied by 0. I get 0. 3 times 2 is 6. 3 times negative 7 is negative 21. Once you multiply 3, you put these temporary numbers here, and you add it to this row. Then I add them. 6 and minus 6 is 0. I replace negative 6 with 0. 0 plus 3 is 3. 6 and negative 10 is negative 4. I put this negative 4. Negative 2 and negative 2 is 0. So look what I did. I changed row 2, but I leave row 1 alone. So these numbers here are just temporarily, but the row 2 are going to be the new numbers. So you're allowed to do such a thing. You're allowed to multiply a row by a number, temporarily write the numbers, and then add it to another row and replace the other row. So I multiplied row 1 by 3, added it to row 2, and I replaced row 2 only. I didn't replace row 1. I kept the numbers as they were. I only changed row 2 to new numbers. The last operation that you're allowed to do is you're allowed to multiply a row by a number. So I'm allowed to multiply row 2, for instance, by 1/2, and then change row 2. So if I multiply 1/2 by 2, 1/2 times 2 is going to be 1 times 2, 2 times 1, 2 over 2 is 1, so this becomes 1. Then I multiply 1/2 by 0. Anything times 0 is 0. Then I multiply 1/2 by 2, but 1/2 times 2 is 1. Then I multiply 1/2 by -7. 1/2 times -7. So 1 times -7 is -7. 2 times 1 is 2. So I get -7/2. So you're allowed to multiply a row by a number. So these are the 3 operations. Swap rows, swap these 2 rows, which I showed you, multiply a row, add it to another row and replace the other row, and multiply a row by a number. So this question number 5 is saying swap R2 and R3. This is R2, this is R3, and it says just swap them. So let's swap them. Row 1 does not get swapped or doesn't change. That's row 1 here. I just wrote it again. But it says swap row 2 and 3. So I write these first. 5, 1, -1, 6. That's my row 3. Now is in row 2. And then I write row 2 here. 4, 5, 4, 6. And that's it. That was this question. Question number 6. For this problem says, multiply 1/2 by row 3 and replace row 3. So this is our matrix: 2, 1, 5, 4, 5, 2, 3, 3, -5, 5, 7, 7, 7. So it says multiply row 3 by 1/2 and replace row 3 by 1/2 times row 3, or negative rather. So I want to multiply -1/2 by row 3. That's my row 3. I want to multiply it by -1/2, but you have to remember to multiply every single one of them. So row 1 is still the same. Row 2 is not going to change. Only row 3 is going to change. So what are the new numbers? We multiply -1/2 by 5. Negative times positive is negative. 1 times 5 is 5. 1 times 2 is 2. So it's -5 over 2. So I multiplied 5 by -1/2. I replaced it by -5/2. -1/2 times 2. Negative times positive is negative. 1 times 2 is 2. 2 times 1 is 2. You get -1. So that is changed to -1. -1/2 times -5. Negative times negative is positive. 1 times 5, 2 times 1. So we get positive 5/2. -1/2 times 7. Negative times positive is negative. 1 times 7 is 7. 2 times 1 is 2. We get -7 over 2. So that's it. That's all you had to do for this problem. Question number 7 wants us to multiply 2 by row 1, then add it to row 2, and then replace row 2. So what is row 2 going to be? Row 2 is going to be this operation. I have to multiply 2 by row 1. add it to row 2, and that is going to be my new row 2. So let's write the matrix. I have 5, 5, and 5, 2, 4, and 1, 4, 1, and negative 2, 5, 7, 9. So, it says multiply 2 by row 1. So let's multiply with 2 by row 1. 2 times 5 is 10. 2 times 2 is 4. 2 times 4 is 8. 2 times 5 is 10. So you have to multiply 2 by every single number on row 1. Then we are going to add it to row 2. So we add 10 and 5. That becomes 15. We add 4 and 4. It becomes 8. We add 8 and 1. 8 and 1, this becomes 9. We add 10 and 7. This becomes 17. So those are the new row 2. And we get rid of these, we get rid of that, and rid of these. So that's my new matrix. Okay? So why do we do all these operations? We do all these operations so that eventually, we want to have a matrix that looks like this one. We want to eventually do the row operation so that our final matrix looks like one of the examples we did earlier. So if you remember, we did this matrix earlier. If we do those operations and we come up with a matrix like that, where we have 1 on the diagonals, 0 elsewhere, then the solution to x, y, z is here. So that's your solution. You're done. So if you have 1 on the diagonal and 0 under the diagonal, then we say this matrix is on the row echelon form. So these not necessarily need to be zeros. They could be other numbers, but as long as you have 1 on this row and 0 underneath, then we call it row echelon form. So a matrix is in row echelon form if it satisfies the following conditions. Any row consisting entirely of zeros are at the bottom. So if, let's say, you do the 3 operations, you end up with 0 here. So if you have all zeros, that has to be on the bottom, okay? If you end up with a row that has all zeros, that has to be on the bottom. For all the other rows, the first non-zero entry should be 1. So this is 0, but this is not 0. So this number here should be 1. And then the leading 1 in each non-zero row is to the right of the leading 1 in the row immediately above it. So if I have a 1 here, then the row above it, its 1 is on the column before it. And the 1 on the column, on the first column, is right before it. So those are the conditions. Another way of saying it is you have to have 1 on the diagonal and 0 elsewhere. If you have a row that has all zeros, that has to be on the bottom row. So if you have a 0 here, that's fine, but it has to be on the bottom row. Is it okay if I have a 9 here, 8 here, and 2 here? Yes, this is still in the row echelon form. So it gives you an example like this: 1, -3, 1, 3, 0, 1, -3, -7. It says, is this matrix in row echelon form? You say yes. Why? Because look, you start after 0, every entry starts with a 1. I have 0, then 0, then the entry here is 1 on that row. Then, or you have 1 on the diagonal, 0 here, and I don't care about these numbers. So the answer is yes. So another example, so I just want to give you another example here. Let's say, let me just change these a little bit. I just want to make up some other numbers. So let's say I have a row of all zeros. I have a 5 and a 2, and this is -30, and then I have a 1 and a 2. Is this in row echelon form? The answer is yes, because after 0, my entry is 1. And then when I go to row above it, the 1 is here. And then the last row is made of all zeros. So if you have a row of zeros, is at the bottom, diagonal has 1, and that's it. Then we say this is in row echelon form. If I had a 4 here, then this would not be in row echelon form because this is a 4. Or if I have, so this is question number 9. If I have a matrix that, let's say, looks like this, this is not in row echelon form because you're supposed to have your ones like that. And these guys have to be 0. So then if it asks you what are the problems with this, you say the leading 1. Do you see the leading 1? In each non-zero row is to the right of the leading 1 in the row immediately above it. So then it's in the row echelon form, and this one is not following that condition. Let's go over question number 10. We have a matrix that is way bigger than 3 by 3. Let's say we have 1, 0, 0, 0. So it has 4 rows and 4 columns. So then I have a 0, 1, 0, 0. Then I have a 0, 0, 1, 0, and 0, 0, 0, 1. I have 1, 1, -2, and 3. And the problem says, is this matrix is in the reduced. So it's not only row echelon form, this is in row, when I had a 1, this was on row echelon form. This is called reduced row echelon form. So now we have a reduced. What is a reduced row echelon form? It has 1 on the diagonals, zeros above the diagonals, and zeros below. Do you see all zeros here? Above and below, it's zeros. On the diagonal, you have the 1s. So this is called the reduced row echelon form. If I had a row of zeros, that's also possible. If I have a rows of zeros here, this is still in the row echelon, reduced row echelon form. So we want to solve, now that we have done all these things and learned these terminologies, we want to solve the following system. We have 2x plus 7y equals to negative 15. X plus 4y is negative 12. We have a system of equations. We want to solve for x and y. So when you create these augmented matrices, you want to have a 1 here if it's possible. So in other words, I look at these equations. Do you see I have a 2 and I have a 1? So I'm just going to write this equation first, which is 1, 4, and negative 12. And then write this equation, which is 2, 7, and minus 15. And that is totally fine. You can do that. So before you start your matrix, create your augmented matrix, make sure your first entry is 1, if possible. For instance, let's say if this is a 4, I cannot do that. So I would leave it as 2, 7, minus 15, 4, 4, negative 12. Because it doesn't matter which equation I write first. But if I do have an equation that one of the x's is 1, like the one we had earlier here, then I should write that equation first. Then I should write this equation first because x has a 1 coefficient. Because of the 1, I wrote it first, and then I wrote that one second, and that's totally fine. Now that I have done that, our goal is to write this in reduced echelon form. What is reduced echelon form? That means I want to have a 1 here, 0, 0. And then the answer, the solution to this problem, the solution for x and the solution for y, some number for x, some number for y would be here. That is my goal. So I already have a 1 here. So do you see this 1 and 1 are the same? Then I want to have a 0 for 4, but I'm not going to go and turn this to 0. I have to work one column at a time. So I have to turn this column, make this column 1, 2, look like that first. Then once I have a 1 and 0 instead of that 2, then I move to the next column. Then I go to this column and make that one look like that. So you work one column at a time. So this is already 1, but how do I turn 2 to 0? Remember, we have 3 operations. We could swap rows. We could multiply a row by a number. We could multiply a row by something added to another thing. So every time you want to have a 0, multiply a row by a number and add it to the other row to get your 0. This is the operation you should do to turn something to 0. So I want to turn this 2 to 0. I multiply first row by negative 2. So I get negative 2 times 1 is negative 2. Negative 2 times 4 is negative 8. Negative 2 times negative 12 is positive 24. Then I will add negative 2 and positive 2. Negative 2 plus 2 is 0. Negative 8 and positive 7. That gives me negative 1. 24 and minus 15. That gives me 9. 24 minus 15, that's 14. Yeah. So I get 9. So what is my row 2 going to be? 0, minus 1, and 9. So every time you want to get a 0 someplace, this is the one you go to. And then we have 1, and then sometimes you can swap rows. If we come across something like that, I will explain it to you. So do you pay attention? I did not change row 1. I left it as it was, 1 for negative 12. I only changed row 2, and I did get the 0 I wanted. So I'm done with column 1. Now I go to column 2. So when you go to the second column, or when you start a new column, always get your 1 first, then get your zeros. So I need to have 1 in this location because I want to make this looks like this matrix. So I go to the next column, and you always get the entry, one of the entries that has to be 1 first, then you go after the zeros. So I want this negative 1 to turn into 1. I'm allowed to multiply a row by a number. So I'm going to multiply negative 1 by row 2. Why? Because negative 1 times negative 1 is going to be 1. So I go negative 1 times 0 is 0. Negative 1 times negative 1 is 1. Negative 1 times 9 is negative 9. So this is my new row 2. My new row 2 is 0, 1, negative 9. And row 1 is still 1 for negative 12. So now that column 1 is fixed, I'm working on column 2. And when I went to column 2, I wanted to have a 1, and I did get my 1. And now I want to turn 4 to 0. Remember, when we want to get things to 0, we have to do this operation. So I have to multiply this row, because that's my only other row. I multiply it by negative 4, and multiply this row by negative 4. Every one of these. Negative 4 times 0 is 0. Negative 4 times 1 is negative 4. Negative 4 times negative 9 is 36. And then I add it to row 1. So let's see what we get. 0 and 1 is 1. Negative 4 and 4 is 0. 36 and negative 12 is 24. So we don't change row 2. These are temporaries. These are temporary numbers. This is what we change to. We change row 1 to 1, 0, 24. This is in the reduced row echelon form. We have 1 on the diagonal, 0 elsewhere. So this is 1x. This is 0y equals to 24. 0y is just 0. You get x is 24. Here I have 0x plus 1y. 0x is 0. I get y is negative 9. So our solution is 24, negative 9. That means if I substitute 24 for x and substitute negative 9 for y, I get negative 15, because 2 times 24 is 48. 7 times negative 9 is negative 63. And 63 minus 48 is 15. Since 63 is negative and 48 is positive, we get negative 15. The same thing here. If you substitute 24, the same numbers, and negative 9 here, you get 1 times 24 is 24. 4 times negative 9 is negative 36. 24 take away 36 is negative 12. So that number, 24 and negative 9, works for both equations, satisfies both equations, so that we call that the solution to this system. I do the next two problems later.